Welcome back to Bargaining in War. In past lectures, we've looked at how cheap talk communication fails to convey anything meaningful, and as a result, does nothing to stop wars from occurring. The central problem, as you will recall, is that it is free to lie. There are no consequences for trying to pretend to be something that you're not. As a result, less resolved types can freely lie and pretend to be more resolved, knowing that if those messages were to be believed, those less resolved types would receive a better negotiated settlement. But if the problem of cheap talk communication is that it is free to lie, then perhaps the solution is to make the signals costly. And that's what we're going to explore in today's lecture. If the signal is costly to send, can we get credible communication where only the more resolved types are sending the costly signal and the less resolved types are sitting it out? To answer that question, we need to write down a new model. Instead of having a fully fleshed out game tree, which will be more of an inconvenience than a help, I'm just going to write down what the setup looks like. The game will begin, as always, with nature drawing B's type. It's either going to be a low resolve type or a high resolve type. In most of these models, we write this down as with Q and probability 1 minus Q. But for this model, it turns out that the research question that we're ultimately going to address doesn't really need to have a prior belief defined as Q or 1 minus Q. But you can think of that in the back of your mind if you want to keep track of everything. Like normal, the low type is going to have a valuation of the prize as VB, and the high type will have a valuation of the prize as VB prime. After nature has drawn B's type, B, which is fully informed about its own preferences, whether it has a low or high resolve, or a low or high valuation for the prize at stake, well, B is going to choose whether to arm or not. This is going to cost K some positive quantity. It's going to cost some sort of money for B to arm. And this will be publicly observable. So A does not see B's type, whether B is low or high resolved, but it does see whether B has chosen to arm or not. Actions like in part 2 here are very commonplace in international relations. In fact, even as I'm filming this right now, Russia is sending troops to the border with Ukraine. That is a costly type of armament. Russia has to spend money to transport those troops there. They're not going to be able to recover all of those funds that they need to pay to get those troops there. And it's something that's publicly observable. The other effect that arming has is to shift the balance of power in favor of the country that's doing the arming. And we'll see that in a moment. After B has chosen whether to arm or not, A will make a proposal. And this is going to be just like it would normally be. It's going to choose a demand X between 0 and 1, just like we are always familiar with. After A has made that proposal, B will finish the game by accepting or rejecting. That's it. Now, I mentioned a moment ago that the war payoffs will depend on whether B has armed or not. So let's take a look at what those payoffs are going to look like, depending upon whether B is armed or not. It will help to have a 2x2 table to keep track of everything. So we'll have whether B has armed or not armed in the rows, and whether B is high resolved or low resolved in the columns. We'll do the non-armament cases first, because that's just going to match up what we've seen before. So the war payoff, if B is the high resolve type and has chosen not to arm, it's going to be 1 minus P, that's its probability of winning in a war, minus its disutility for fighting, which is going to be CB divided by VB prime, because this is the high resolved type. Now, it's actually important that we're using the valuations here, because that's going to impact what's happening in terms of how the high resolve type versus the low resolve type is going to internalize the cost of arming, which again we'll see in a moment. The low resolve type has a war payoff that's very similar. It's going to get 1 minus P, again that's the probability of winning, minus CB divided by just regular VB, because it has a lower valuation here. Okay, now let's take care of the arming payoffs. So arming is going to do two things. First, it's going to shift the probability of victory favorably toward B. And second, it's going to cost something. So for the high resolved type, that armament payoff is going to be 1 minus P plus delta, where delta is just going to be some value greater than 0, which is going to increase that probability of victory in favor of B. B will still pay its war payoff, or war costs, of CB divided by VB prime. And what's going to be different here, of course, is that there's also a cost of paying for the armaments, which in this case is going to be K divided by VB prime. You can think about that K value as being the direct financial cost, but because we are having to think about the resolve of B, we are tying everything together based on how much B values the prize. So the way that B will internalize the financial cost of armament is going to depend on whether it cares a lot about the stakes or not. And so just like what we have with the war costs here, we're also going to be dividing off VB prime for the cost for armament as well. Same thing over on the right side here for the low type. We have a probability of victory, which is 1 minus P plus delta. The cost for war is CB divided by VB. And the cost for arming is K divided by VB. Once more, this is because the low resolve type values the prize at a lower amount, and as a consequence, we'll be internalizing each of those costs at a greater quantity. Okay, now that we have all of those war payoffs organized, we can get to the central research question for today. And that is, when does the high resolve type want to arm, and underline that 3 times to emphasize this is the fact that we're asking this question simultaneously. When does the low resolve type not want to arm? Going back to the cheap talk lecture, the problem there is that both the high and low resolve types want to send the high resolve message. And as a consequence, the communication is meaningless. Here, we're trying to investigate whether we can get true separation. So the high resolve type is arming, and the low resolve type is not arming. Thus, if you put yourself into the shoes of A, you don't necessarily observe the type directly that you're facing. You don't know whether B is high or low resolve directly, But if you're observing whether B is choosing to arm or not, you're getting all the information that you need. Because if the types are adopting this separating strategy here, if A observes armament, then implicitly it knows that B has high resolve. And if A does not observe that armament, then implicitly A knows that B is low resolved. Fortunately, answering this question is straightforward. It's actually two questions. One, given these expectations, is it true that the high resolve type wants to arm, given the alternative that it would receive if it were to not arm? And two, again, given these expectations, does the low resolve type not want to bluff strength by arming, given what it expects to receive by doing so? Well, let's get to answering those questions, beginning with the high resolve type situation. If the high resolve type arms, then A has effectively complete information about what's going on. It knows it is facing a high resolve type and that the high resolve type has armed. As a consequence, it is going to propose an amount that will leave that high resolve type indifferent between accepting and rejecting. In other words, it's going to give the high resolve type its war payoff. And that amount is 1 minus P plus delta minus CB divided by VB prime. That's how much the high resolve type is going to receive through the agreement. This is not, of course, the overall payoff for the high type arming, because by virtue of the fact that it is armed, it is also paying that cost. Its alternative is to not arm. If the high type does not arm, then A's belief is that it is actually facing the low resolve type. And it's going to offer an amount to the low resolve type, or at least what it thinks is a low resolve type, that is insufficient to satisfy the high resolve type. So ultimately, this means that the high resolve type is going to fight a war. When it fights the war, it is not going to get the benefit of arming, but it's also not paying the cost to do so. So its war payoff here is rather simple. It's what we're used to, which is 1 minus P minus CB divided by VB prime. Thus, the high type wants to arm as long as this inequality holds. And in fact, it can be a little bit weaker. We don't actually have to have a strict inequality there. We can have a weak inequality. And it would still be the case that the high resolve type does not have a profitable deviation. Well, you'll notice that the 1's cancel on both sides, minus p's cancel on both sides, these cost parameters cancel out on both sides. We're left with delta greater than or equal to k divided by vb prime. And if we solve for k, we get k less than or equal to vb prime times delta. Okay, so that's our first key point. We need this to hold. Let's put that in our back pocket for now, and we'll come back to it later. The next question is whether the low type does not want to arm, because we need both of those things simultaneously. If the low type does not arm, it is giving itself up to A. It is basically waving a white flag and saying, look, I'm the unresolved type, because only the more resolved type is the one that's doing the arming. This is why those initial prior beliefs that A might have are irrelevant. Because if we have these fully separating strategies, where the high resolve type is arming and the low resolve type is not arming, then the prior beliefs go away and A is facing certainty thereafter. Well, if the low type is not arming, then A is going to offer an amount that is commensurate with the current balance of power and the fact that this type has low resolve. And so that war payoff is going to be 1 minus P minus CB divided by VB. This is the low type's war payoff. It is not receiving that quantity through war, but rather it is receiving that quantity through the proposal that A is making. And A can get away with this because A knows that B has the low resolve by virtue of the fact that it has not armed. If the low type arms instead, this payoff is going to be a little bit tricky. Under these circumstances, the low type will have successfully fooled A and convinced A to make a proposal commensurate with not only the armament, but also the alleged fact that B has high resolve. And as a consequence, this is going to look somewhat attractive. The payoff here from the proposal will be 1 minus P plus delta. That's the probability given the balance of power here. And then here's where things get a little bit tricky. The amount that A is going to extract is going to be CB divided by VB prime. Now that VB prime part seems a little bit weird because we're talking about the low resolve type. But remember, A has been tricked, and so A is making its proposal based off of what it thinks to be a high resolve type. And the amount that A needs to propose under that circumstance is this quantity here. As a result, the benefit that the low type is receiving by bluffing is the fact that it is getting a better deal because, again, A is making a demand commensurate with the high resolved type's payoffs. The downside, though, is that the low resolve type still has to actually pay the cost for building those arms. And so we're going to subtract out K divided by VB. It is not VB prime here because the low type is actually paying this. This part is coming from the proposal. This part is coming from the fact that, again, the low type has actually paid that cost, and it is weighing that cost according to its true resolve, which in this case is the low amount. What we're looking for is when this relationship holds. That is, when the low type is happy to not arm, given what it could be getting by arming. Well, we can do a little bit of simplification here. The 1 on both sides goes away. The minus P on both sides goes away. We're going to try to solve for K again. We get K divided by VB, moving this over to here. And then we have a delta and a plus CB divided by VB minus CB divided by VB prime. So we can simplify this by multiplying the VB over there, or at least to get this in terms of K. And we can also undistribute these CBs. So if we do all of that simultaneously, what are we going to get? We're going to get a delta multiplied by VB. We're going to get a CB with a VB divided by VB canceling each other out. So we'll just erase that right now. Minus a CB times VB divided by VB prime. And so to actually undistribute those CBs, do that now, it's 1 minus VB over VB prime times CB. This is a fraction that's between 0 and 1. So when you take 1 minus that quantity, this is a 0 to 1 interval as well. But we now have the two things that we need, and very conveniently, they're both on the screen simultaneously. We need K to simultaneously be less than or equal to VB prime times delta, and greater than or equal to delta times VB plus the quantity 1 minus VB divided by VB prime times CB. Can there ever be circumstances where both of those things are true simultaneously? Well, let's address that question now. Let's examine whether we have situations that can ever look like the following. We need to have delta times VB plus 1 minus VB divided by VB prime times CB to be less than or equal to the other one, which is VB prime times delta. So if we have circumstances where this is true, then it is possible for K to fall in between those two values. And when it does that, going back to what we've seen up here, when K is larger than delta times VB plus 1 minus VB divided by VB prime times CB, when we're in this situation here, K is so expensive that the low type does not want to arm, whereas simultaneously, K is cheap enough that the high resolve type is willing to arm. Now, the reason that this could possibly be the case is that the high resolve type internalizes the cost of armament at a lower rate. Thus, they may be willing to pay the price, and in fact, a price that the low resolve type is unwilling to do. Well, getting back to the central inequality, we can't really do too much to this, other than perhaps move VB and delta over to this side. And if we do that, just rewriting this a little bit, we have this inequality here, and this is pretty much where we're going to have to stop. This is one of those things that could be true or might not be true, depending on what the actual parameters look like. The key thing, though, is that under some circumstances, this does hold. And you can note that by just looking at the left-hand side and thinking about what happens when CB is relatively small. In fact, as CB is going to 0, because this right-hand side has to be positive, then the inequality will be fulfilled. And we will have circumstances, which we would describe in this literature as incentive compatible, where, again, the high resolve type wants to arm and the low resolve type does not want to arm. In other words, we finally have communication working. That's kind of exciting. One interesting thing to note here is that higher costs for war make it harder for communication to work out. And thus, in some complicated sense, when we have higher costs for war, we actually might get more war, not less war. The reason that that's happening here is that the incentive, the temptation the low resolve type has to bluff high resolve is that the proposal that A will then make is going to be based on the high resolve type's war payoff instead. And when you make CB increasingly large, the difference between the low resolve type and the high resolve type's war payoffs is going to expand. And the larger it expands, the bigger the temptation that low resolve type has to bluff high resolve, so it will get a much larger proposal. That wraps up this lecture. I hope you enjoyed it, and I hope to see you next time. Take care.